Hello, today I'm going to discuss 120/240 single phase power that comes into your house and the 7200 12473 phase that you see out on the poles. So let's just show you how this works. So basically first, you have your pole. Wood pole, buried in the ground 5 to 7 feet. And then you have insulators, which pretty much don't let electrons flow through them easily. So you got your 3 insulators up here. Nice drawing they run. And you got your neutral down here. So, you gotta connect to the pole. Conductor supports, usually 5/8 volts. Alright. First things first, we need to ground everything for safety. And basically, you'd be like short circuit, down the ground, and there's a secondary connection in case one of the grounds fails. So basically, you ground with this. But we're talking live power here, so you'd have L1. That'll be your 7200 12470. Any one of these conductors to ground is 7200 volts. 2 and L3. Black, red, blue. L3. Any one of these to ground or neutral, grounded conductor. These would be your ungrounded conductors up here because they're live. They touch anything, they catch fire. But any one of these to this neutral is 7200 volts. But if you grab any two of these three, any pair of these three up here, you got 12,470 volts. Basically take your single phase voltage 7200 times the square root of 3, which is 1.73. And that'll give you your 3-phase voltage for that. So what? 12473 phase, 7200 volts to ground. So then when you get a transformer, you put a transformer pole. You got your high voltage and your center tapped low voltage. Take your transformer, ground this, take it to neutral. And then we have, in the single phase system 120/240, we have L1 and L2 here. And basically, this is 120 to neutral, 120 to neutral. L1 to neutral is 120, L2 to neutral is 120. But you take your L1 to L2, you got 240 volts. For like your stove, furnace, air conditioner, dryer, big appliances. But everything else is 120 to ground. Basically, this would be like one circuit. The L2 would be the red, but it would power half your house, and the black would power the other half of your house. You bounce the load across that, that's how it works. So basically, you'd have 3 wires coming off here. You got your, use ground for that. You got your center conductor, load bearing conductor, grounded, neutral. Well, in a single phase system like this, it's called the grounded conductor. And you'd basically have your L1 twist on there like that. And you would have your L2 twist on there like this too. It would come to your house, goes to the meter socket. L2 on the right, L1 on the left. Neutral in the center, and basically measures the power you use. Simple as that. Oh, wait a minute. We need this though. Yeah, you would have to connect your high voltage to that too. And you can see how that would work. Oh, you gotta put the iron core in there. Don't forget the iron core. So you got your 120/240 going to a house. Goes to a house like this. Basically, you'd have lighting circuit, and you'd have your plug. Let's say. Plug, and plug. Small part of the plug's the live part, that part's the ground conductor. So basically, your L1 will go half a circuit, join there. L2 will go there, half a circuit. And then here, next to that half a circuit. And then this half a circuit goes to the ground conductor. Bang, bang. And your ground conductor just comes in here like this. Green. Green out. Your ground conductor comes in here like this. And it connects to this half. Everything in your house is in parallel. Because if everything was in series, you'd unplug one thing and everything would shut off. Here, I'll show you. Let's see. So, here's your series circuit. Here's your parallel circuit. Parallel circuit. And you can also have your series parallel circuit. Let's see how I can do this. And you have another load here and another one here. And I mean, and this would be your series parallel circuit. That's a whole other animal, but pretty much everything works that way. And basically, if you remove one of those, if you broke the connection, that would go out. I mean, you can see that series, parallel, parallel, series. You got it. And basically, then you'd have your stove. Let's see, dryer. And it would be connected like this. And that would go there. And this would go like this. And there you can see how that will plug in. 240 to your dryer in that. I mean, I tell you what, I couldn't illustrate that more simply than that. Yeah, I know you're supposed to not have any markings or anything on your ladder, but I put Ohm's law, some conversions, and my feet and inches on there. Feet and inches, all the way up to 5, 6 feet. And you can see how I did that.